Hello everybody, welcome to the second neoPLC tutorial. Today we're going to connect a neoPLC microcontroller to an environmental sensor. So this should be fun to see how quick and easy it is to get these sensor and input-output boards running. So what we've done here, you'll remember last time we just connected the microcontroller to see that it could talk to the phone, and we're able to change the code to make it blink. And we made sure everything was connected. So if you're having hard times communicating with your microcontroller, we recommend you go look at that first tutorial. But today we're gonna just get this and connect it to the environmental sensors. So what we've done here is I've added pin headers. I've soldered pin headers onto both the microcontroller board and to the environmental sensor board. So you see just a set of, on the microcontroller, we've got a set of 5 pins here on the edge, and on the environmental sensor we've got 4. Most boards, all the boards are fine to run with 4. We would recommend putting 5 pins on the edge of the microcontroller because that lets you connect it to the battery board, but otherwise they all use 4 because they all speak a language called I2C, which you can read on the website more details about that, and we'll get into that in a minute too. What is I2C? And so we got these two, and the way we're going to connect them, we've got these pins soldered in, but I don't want to solder these two boards together because this is just for prototyping. So we've got this little double female header, which is going to let us connect them together. So I'm going to get here and connect this. Just slide this into the 4 pins, and if we look, we're going to line these two boards next to each other and connect them together with that header. So kind of do this from the top so you can see it as best as possible. And we're going to slide this down, and you see they are connected together right in the middle, and that's going to let them communicate. Okay, so now all the neoPLC rather boards talk to the microcontroller with a language called I2C. We use I2C because that's what lets us clip these together so easily. In fact, it doesn't matter how many of our different boards you connect together. Each of the different boards can kind of be chained along, and that's what lets you make really cool projects with neoPLC. So for instance, we've got these two, but we could add any other. We could add a screen, we could add an IMU just as easily by putting some pins on or soldering them together, or putting them in a stack. So here's kind of a neat example of something we'll probably talk about in the next tutorial. So this is a stack with a microcontroller, and in the middle, you can't see, is an IMU, and on the bottom is a GPS. So this is like a navigation computer, and it's got all kind of parts. The whole cube here is less than 1 cubic inch, and this is actually one of the things that got me into designing neoPLC. Is I was looking for actually something very similar to this, where I could get a GPS, an IMU, and a controller all together, and there's very few ways to do it, and definitely not in a neat package. So look how compact this is. When we solder the neoPLC boards together, we end up with this nice compact system that we can hide away in whatever we want as we build our hardware. Okay, so for now we're going to check these boards. So we got microcontroller and an environmental sensor. We're going to be back in Arduino, but I'm going to go ahead and plug this in like so, and the light is blinking from the last tutorial where we just controlled the blinking. Alright, so we got this, and going to go turn on Arduino, get this fired up. Okay, so the first thing, before we even actually talk to the environmental sensor, I'm going to go in and make sure that the board has been found by the microcontroller. Okay, so when we start Arduino, we end up with this blank script. And so the first thing we're going to do here is we're going to go open the example that we call the scanner. So we're going to go to examples, down to the wire library. Wire is what they sometimes call I2C because it's the 2-wire serial communication technique. So in the wire library in neoPLC, go to wire, and we open the scanner. Now what this is going to do is it has some code. It's a lot of code, a lot more than we saw in the last script, but if you take some time and read through it, you'll see what it does is I2C is based on each chip having a unique address. So what this script is going to do is it's going to check all the possible addresses from 0 to 127, and we're going to, if we find, and so it's going to call out and see if any sensors respond to that address, which is one of the neat things about I2C, is it lets us check whether sensors have a certain address and whether anybody's talking at that address. So it's going to check them, and if it corresponds, the address, if it finds a chip on an address that we have a neoPLC board, it will tell us which board is connected. So you can see kind of a list of the boards, and we update this every time we add a new neoPLC sensor or input-output board. It goes on this list, so you can always check, and again, all this is going to do is let us see and make sure the microcontroller knows the environmental sensor is connected. Alright, so I'm going to go close that blank script. Okay, now we're going to do something neat here. You see this magnifying glass in the top right corner of the Arduino IDE. This is the serial monitor. I'm going to go ahead and open that up, and you see some gibberish running through here. We'll fix that in a second. But let's get this code loaded. So again, we need to make sure that we have the neoPLC board, neoPLC 1, and the port is the SLAB USB to UART, and we are connected. Okay, close my port, that's okay. All right, and we're gonna upload this. Now we know this example is good because we haven't changed it yet. So this should upload just fine to the neoPLC. And again, what we're looking for is to see that the device is programmed. By the end of the comments here, if it doesn't end in device programmed, then something must have gone horribly wrong in the meantime. So, alright, device program, we're good. Alright, so now the scanner is loaded, but to scan, we're going to go, as I said, we're going to open the serial monitor, which for now is printing gibberish because we're expecting data at the wrong speed. So the default in Arduino is going to be 9600 baud, which means 9600 bits per second. And neoPLC always uses 115,200 baud, much faster. So we need to select that. And you'll see now it starts streaming once a second, scanning, and a device was found. And how about that? It found an environmental sensor. So everything is good to go with the sensors. So we're connected. I'm going to close the monitor. And now we're going to go find the example for the environmental sensor itself, which is the fun part here. So go to examples. Down in the neoPLC examples, we find the appropriate one for the environmental sensor, neo environment. We'll close the scanner. Okay, and now this script is as simple about as you can get, and we'll talk through the critical pieces of it. But first, let's go ahead and upload it and just see what it does. So we hit upload. Again, since we haven't changed anything, there's a very good chance that this works just fine. If not, then again, the things to check are which port are we on, and are we using a neoPLC board definition, and is a monitor at 115,000 baud. Alright, so we've got device programmed. Open serial monitor, and now we've got success. So look, we can see everything that we can get from the sensor, and check this out. So we've got temperature. Right now it's in degrees C. We've got humidity and pressure and altitude. Altitude is actually estimated from the pressure. It's not perfect, but it's kind of nice. And later on, we'll probably use that for navigation. You can use that to augment. It's actually, in certain ways, it's more accurate than a GPS in determining altitude, and in certain ways, GPS is more accurate. You can kind of combine those two to make something really, really nice and more accurate than either of the two. Okay, but for now, yeah. So this is great. We got the data streaming. Just to check it, I'm going to stick my finger on the board, and we should see the temperature rising. So my fingers are not particularly warm, but yeah, so the temperature's going up, right? And so is the humidity, so that's curious. Wouldn't have exactly expected that. Okay, so here we go. Oh, so that's all working. So great. So let's look at back in the code. I'll leave this running over here. And back in the code, let's see what we've got here. Okay, so now all the neoPLC sensors have the same kind of starting, this way we get to the library. We've tried to standardize this nicely. So The most important thing is you got to include the library, the header, which down inside neoPLC, and you can, all this is open source, you can look at it if you want. So this is what they call a library, which is just code we've written, which kind of is gonna, in this case, is gonna talk to the environmental sensor in a special way, and it's gonna give you access to some functions to access that information. So for the sensor, it's gonna be to set up the sensor or to read the sensor, maybe for an input and output board that you control the pins on the board. So we've got this, we got to include, and this is the syntax for including the .h file, which is the header file um, from the core down in the neoPLC core libraries. All right, and then the second step on almost all neoPLC boards is going to be we need to create what we call an instance of the environmental sensor. So we only have one, so this is pretty clear syntax. It's going to be, again, very similar for any neoPLC board. So we say the name of the library, or the type, the class type is actually what this is, but when you type it in, practically you type in the name of the library, which is neoENV. Give it some name, so I choose ENV just because it's a nice short name. Later on, we're going to use that a lot. So I just want a short descriptive name, could have called it sensor or anything. And then we're going to say is equal to, in a way we're saying equal to itself, but what this does is it has some code that lets us create, again, an instance of the environmental sensor. So now this is going to mean we have one environmental sensor connected to the name ENV, env. All right, so now scrolling down a bit, let's see. So in the setup, again, this is the code that runs once. We're just going to do some simple things here. Let's see, I've got a LED blinking, but that's not particularly relevant. The important thing here is I'm going to begin the sensor. So this is going to begin it with and tell it to kind of set up some default values. So now whenever we call something from within the class, we're going to use this syntax a lot. So we've got env, which is a sense we're using, with a period, and then use a function or call a function or get a variable out. They also, if we're being picky, functions in this context might be called methods, and variables might be called parameters. So just for simplicity, I'm going to call this a function. So we get this function from environmental, which is just to begin, a function that says to fire up the engines of the sensor. And we start. And this is going to return us a value, either 1 or 0, saying whether we found it or not. So we expect we found it for a couple reasons, because the scanner worked and because we see it's connected over here in the serial monitor. So it was successful, but if you had the chip unplugged or something, it would probably say could not connect. All right, run that once, and then getting the data from the sensor is as easy as telling it to read the different sensors that are inside it. So we've got temperature is equal to reading the temperature of the environmental sensor. Humidity, we just read the humidity. So this is just a nice clean syntax. And on this chip, it's a sensor, and there's not a lot of options for it. So it's really nice. You can kind of set it up and just expect the data is good. We just read the temperature, and a lot of times at neoPLC we just have the default values to be most accurate, but maybe in some cases you want to go in and modify the library to be the ones that consume the least power, or things like that, most accurate, or maybe we'll compromise how fast the sensor can update for how accurate it is. So in this case we're using the defaults, and we just read them. And then something that we haven't touched in these tutorials yet is this serial print. So this is a very powerful tool for testing your systems before we go and make an app. We can have the chip talk to the computer. So in this case we're printing out the lines which you see over in the monitor, but we're going to print temperature equals, and it's just the string or the set of characters temperature equals. Then we're going to print the value of temperature, and then we're going to print the character degrees C, and make a new line. So again, there's snippets of this on our website, so you can get this, and this is identical to the standard Arduino serial syntax. We also support printf. Talk about that later, but it's a little bit more powerful way, or a little bit more organized way to get to print things to the screen. Okay, and so we just do this where we read a sensor and print it for each of the 4 sensors, which you can see matches the 4 outputs over here in the monitor. And then we got a couple other things going on. So we tell the LED to turn on if it's off and off if it's on. And then we're going to wait for 1 second. So we've got a function here down at the bottom of the script, which is going to regulate the time. And so it would be very easy to come in here. Let's see. So we can comment this out with 2 slashes. We could delay to 1,000 milliseconds. This is almost identical. In fact, if we run this, you're not going to be able to see a difference in the serial monitor output. But the thing is, if I delay for 1 second, 1,000 milliseconds, that doesn't mean that the time it takes from top to bottom is 1 second. That means that it's 1 second plus everything that we've spent time working on up here. So regulate loop is a nice way to make sure that every time that this gets called, the entire process takes 1 second. It takes some small amount of time to get to here, and then regulate loop holds on until the end of the second comes, and then it lets it restart. And then you can see exactly how that works down in the function. All right, and then again back in the serial monitor, you can see this working rather nicely. So okay, so I know that was quick, but just wanted to get everybody started with neoPLC boards and sensors, and you can see one thing that we should have covered in the first tutorial, so I'm going to do it now, is I told you all and showed you that we have some default code that already connects to the app. And if you put something like, if you connect to the iOS app, and if you put this code on your controller, like this code that we've just loaded, it's no longer going to connect because we've removed the Bluetooth information. So we need to load that back in. But it's okay. We've got that as an example. So let's go back to examples and go down to neoBLE and Bluetooth Low Energy is what that stands for. Close this environmental sensor, and we don't need to save that. Close this, okay? And we're going to load this demonstration. And so this one's a nice one for people who are getting into neoPLC for the capabilities with connecting to apps. This is a great place to start to read through this code and see this is the manager. We'll talk in more depth about this in a future tutorial, but this is a manager which handles communication on the microcontroller side, and there's a manager which handles communication on the app side, and both of those are heavily commented and open source on our GitHub, so check that out. But for now, let's see. So we've loaded this. The device is programmed, and if we go back to the monitor, I think we had some comments that got printed here, but we waited too long to open the screen, so they won't show up. But I can go and I can connect to the app as we showed in the first tutorial. So, all right, everybody. Thanks for watching. It's been fun, and hope to see you soon.